In the last video, we covered tongue and groove joints, and we cut the panels to fit those joints. In this video, we wrap up the first half of the build with the lower rail arches, the interior rabbets, and both the work surface panel and the top shelf panels. The most important part of arches is consistency, and to help with that, we're making a plywood template to mark out all of our pieces. I used 3/4 inch plywood for this, but ideally 1/4 inch material should have been used, and for the template I bent a piece of wood around 3 nails to establish an arc. Wood will almost always bend inconsistently when used in situations like this, so to give me a left and a right option for the template, I left the right side as is, and then I bent the left side just a little bit more to give a different look. After making a short and long template, we roughed them out at the bandsaw and then trimmed them down to the line with a spoke shave. Because we're using 3/4 inch thick material for our template, we need to really make sure that our shaped face remains 90 degrees to the parallel faces here of the plywood. That's more important for wider stock than thinner stock. So if you're using 1/4 inch, 1/8 of an inch template material, you probably won't have to do this, but just really make sure you are nice and square if you are using thicker stock. That's important because if we do end up liking this half of the arch more so than the other half, and we use this half in symmetry by flipping the template over to mark our material, then this side needs to be nice and this edge rather needs to be nice and parallel with this edge. After comparing each side of both templates, we decided to only use the modified left side of each one of the templates. This just means that when we mark the material, we have to mark half and then flip the template over for the other half. The process for cutting the final material is the same as roughing everything out at the bandsaw and then using a spoke shave, card scraper, or sandpaper to get down to the pencil line. As far as using a template, you could actually just get one of the final pieces to its final size and then use it as a pattern with a pattern bit on the router table to get all the other pieces to match 100% and make them identical that way. But I wanted to show that you can still get good, consistent results without template routing. Next up is the interior corner rabbets, and all 4 cabinets will have either drawers or shelves inside. The easiest way to accommodate both the drawer runners and the sawtooth shelf hangers is a simple rabbet, and that can be cut on the inside corners. Before doing the final assembly on the cabinets, we decided to complete the work surface panel and top shelf panel so that we would be prepared to do all of our glue-ups and assembly at the same time. After milling to final thickness, we used a few number 10 biscuits to help maintain alignment during glue-up. Right about here is where we realized the change in direction for this project. So from here on out, we set the base cabinets aside for later use and are going to repurpose the top cabinets into something else. The project change included more mortise and tenon joinery for the inside of the cabinets to attach the connecting rails. Just like before, we used a plunge router with an edge guide for these. The front rail's coming from this board, and on this side over here you can see we've got some defects, so we're not going to cut from that side, we're going to cut from this side. But if we were to just go off this already established edge, all of our grain is just really sloping in one direction, and that kind of looks goofy. So to solve all that, we established a new edge that is parallel with the grain, and now we can use this edge to get our rail out of, and it should be nice and straight across its length. With the material selected for the rails, we repeated the milling process once again. The front top rail is exposed, so we took the time to get a good looking piece for it, but because the back, top, and bottom rails will not be seen, we used some material that we had that didn't quite have a good color match. Areas that won't be seen like this are a good way to use up some of the less than perfect stock. All 3 connecting rails get a tenon cut on each end, and to do so we used the same process as before, but because we only had to cut 6 tenons instead of 64, we cut them with just the regular table saw blade instead of the dado stack. To reduce confusion as well as tool setup time, we sized all of the mortise and tenon joints to be the same. Just to recap the mortise and tenons here, we've got a round mortise and a square tenon. So you have 2 options. Number 1, well, 3 options actually. Square the mortise is option 1, round over the tenons is option 2, or just take the radius here, in this case is 1/8 of an inch, and cut this shoulder 1/8 of an inch further in, and that way you don't have to do much paring or chisel work or anything. So this is the front top mortise and tenon, or front top rail I should say, and I think I had that backwards, yeah. So that's the front top one. The back bottom rail is completely identical. Everything is 100% identical to it. And then the back top rail is not. The joint is identical. This mortise and tenon joint is the same size, but it's offset to one side on a wider board. The reason being is I need this extra material over here to cut a 45-degree angle to establish a French cleat to hang the entire cabinet when it's all said and done. We're getting really close to being able to assemble this thing for the final time, but before we do, we need to make sure all of the little details are taken care of, and one that really sticks out is the tabletop hold-down clip grooves. So we're going to attach the top and bottom panels with these little hold-down clips. Let me bring you in a little bit closer and show you how these work. This little guy is a tabletop hold-down clip, and there's several different styles and names and all of that good stuff. I've always called them tabletop hold-down clips. I buy them in bulk on Amazon. But basically what this allows you to do is attach a solid wood panel, which in this case the workbench, to a rail, and still allow expansion and contraction due to wood movement. So we can screw through this into the solid panels that will be on the top and bottom of the case, and have this side go into a slot. And you want that slot to be just a little bit more so than this height right here. So if I hold this flat, whatever height that is, increase that. So I think that's about 1/2 inch. That allows the screw to maintain downward pressure, so we do have the tabletop being secured firmly to the rest of the cabinet. But this side goes into that groove, and what that allows is, as the tabletop has seasonal expansion and contraction, it can slide in and out of the groove while still being held in place as it should. To cut the grooves, I have my table saw fence set at 1/2 inch away from the blade, and the depth of the cut to be 1/4 inch. This is the front rail, and it needs an arch cut on it on the bottom side so that the center point is 1 inch away from the edge. And I've just positioned a couple clamps over here so I can bend something around them to get that perfect arch. Now, as far as what to bend around it, I'm not using a piece of wood, and the reason being is wood is very rarely consistent. In this case, if I bend it, I'm bending this piece, and I don't know if you can see it, but on my left, let me look at the monitor so I can see. On my left, it's bending quite a bit more than on my right. It's just not a consistent bend. So there's too much variation with wood. I always like to find something else that is a little bit more consistent. In this case, a big drywall square, and this will bend around with no problems. And the resulting arch I can trace, and it's way more consistent than that piece of wood was. The same process of using the bandsaw to rough out the arc and then a spoke shave to get to the cut line is used for the front arch rail. The front arch turned out really good, and when we put the top on here, it just really flows. It connects the two together rather than just a regular straight rail. So we're dry fitting that, that's good. The bottom back rail is dry fit, that's good. The back top rail needs to be cut at 45 degrees on the bottom side for a French cleat. Those two mating 45-degree angles create a French cleat. So if you're not familiar with what a French cleat system is, pretend that this is attached to the wall. So this is the wall. Actually, I'll just rotate the camera on the computer. So this is the wall, and this board is attached to the wall. This board is attached to the cabinet. So instead of wrestling around the cabinet trying to get it in position and hold it in place while you secure it to the wall, all you have to do is hold the smaller, much more manageable piece up against the wall and secured it to the wall studs, and then you simply take the cabinet, slide it over the top, and set it into place. French cleats are just fantastic for hanging cabinets or anything like this. 45-degree angles are also really sharp and delicate, so to prevent these from breaking off, I'm just going to hit them with a block plane real quick, just to take off that sharp edge. The interior shelves will be adjustable, and in the interest of trying something I haven't tried before, I chose to go with a sawtooth shelf bracket system. I needed 8 of these hangers for the 2 cabinets, so to cut down on the number of cuts as well as increase the accuracy from one piece to the next, it makes sense to mill a larger block into the profile needed and then rip the 8 individual brackets out of that block. I made the first vertical cut in the board without the sacrificial fence on my miter gauge, and since then I've installed it, and basically this is nothing more than just a simple box joint jig with an alternate spacing. So this spline represents the exact same thickness as the blade, and it is offset so that the left side of the spline is 1 inch away from the left side of the blade. Now I can make all of my cuts to evenly space all of the verticals. So the first one that's already cut, I can set it down on top of the spline, and that positions me left and right. I'll make a cut, pick the board up, and then put the new kerf onto the spline, make a cut, put the new kerf onto the spline, and so on and so on. And I think there is 12 or 13 of these cuts on the sawtooth hangers. I tilted the blade to 45 degrees for the other cut, and as far as the left and right placement, it's just a matter of removing the screws holding the sacrificial fence to my miter gauge, and then just eyeballing the placement left and right. Now, something that really helped me out is I took a scrap block and I laid it against the carbide of the saw blade so that it references nice and flush. And then I can push my workpiece up into it, or actually slide this block back to my workpiece and really extend these teeth into the workpiece so I can see exactly where it's cutting, and then I can dial it in left and right to really verify its location. Because the last setup created another kerf cut into the sacrificial fence, when the 45-degree angle is cut into the fence, a small triangle of supporting material is cut out on the fence. I had to glue this piece back into place before making these angled cuts so that there would be material in the fence to push the waste piece forward and past the blade and not get trapped between the blade and the rest of the material. I have the board sitting so that the last kerf that I have remaining is straddling the key on the fence for my miter gauge. And as you can tell, I can't make that last angled cut in this orientation. I need to shift over once more, but I don't have anything to reference my key against, so instead I'm going to rely on measurements here. I know that my initial spacing for the vertical cuts was exactly 1 inch. So what I can do is use this stop block up against my material, with the material once again on top of this key in this last kerf, slide my fence up against that block, and that gives me a distance on my scale, and I can move over by exactly 1 inch, and that is exactly 1 inch right there. So now I can remove this fence and use this with my miter gauge and this stop block to make that last cut. Now that the profile is established, 8 1/2 of an inch thick brackets can be ripped out of the block, and we actually cut 10 of them just in case one broke. It's a good idea to cut extra with stuff like this, but luckily we didn't need any of the extras. Next up, we cut the top and bottom panels to their final size and set up for the coves on the table saw. Sean recorded this video for his channel, but it's a very basic setup. Basically, set the blade height to match the desired rise of the cove and angle the sacrificial fence so that it intersects the center of the blade, and the distance from the fence to the opposite side of the blade at its furthest forward position is equal to the desired run of the cove. Once the angle is determined, we put a pencil line on the table, clamped the fence to the table on the pencil line, and slowly raised the blade with the motor on to take about 1/16 or 1/8 of an inch per pass. After a test block confirmed our setup was good, we ran both the top and bottom panels, and cutting coves on the table saw is a great way to get a custom profile that you may not have a router bit for. The only downside of this is that it produces not so clean of a cut as a router bit will, and it oftentimes requires a lot more sanding and touch-up work. All of the case components are now complete, so we can do the assembly stage. Now before assembly, I want to pre-finish all of the panels. The reason being is if I complete the project and then apply my finish and the panels shrink, it exposes some of the panel that doesn't have any finish on it. So to prevent that from happening, we're going to pre-finish the panels do all the glue up with the assembly, and then at a later date, if the panels shrink, well, it just exposes some more material that is already finished. Before we do any of the finishing though, we want to do a little bit of surface prep. And to do so, I've got sandpaper, a card scraper, and a hand plane. And basically, there's a couple different reasons why you would use each one of these. I always tend to go for the hand plane first because it's the most efficient use of my time. It removes the most amount of material, and I can dial it in to really determine how much material I am removing. It's slicing layers off the top. Next up from that is the card scraper, and you're scraping layers off the top. This is a little bit more forgiving. Actually, it's a lot more forgiving if you run into situations where the grain just isn't cooperating, the grain is going in multiple directions, and the hand plane is causing tear out over that multi-direction grain. So then we would switch over to something like this, a card scraper, or a cabinet scraper, which I have right here. Cabinet scraper will do the job just fine as well. And then beyond that, if you just want to make sure that the entire surface is at a uniform texture or a uniform, well, I guess texture is the right word before finishing, then you would switch over to sandpaper. Also, Mark Spagnuolo, the Wood Whisperer, released a video recently on showing the differences of how a finish actually looks on top of sanded material, scraped material, and hand plane material. And I encourage you guys to check out that video. I'll have a link in the description. But basically, if you slice off the material, if you're using a hand plane, it's a cleaner cut. So the finish actually has a little bit more contrast to it rather than sandpaper where you're just basically crushing the fibers and embedding them into the rest of the wood. So if you want a more of a contrasty finish, then definitely try your best to get all the surface prep done with a hand plane. If you want something that's a little bit more even, which in this case we want to not exaggerate some of cherry's traditional blotchiness, so we're probably going to do the bulk work with the hand plane and scraper and then switch over to sandpaper to just kind of dull down all of the fibers and hopefully reduce some of the contrast. For a finish, we're using Garnet Shellac because shellac itself is a very forgiving finish. It burns in as each layer is applied, so you can kind of manipulate the layers below very easily if needed. And the garnet color is commonly used on cherry or other species where a reddish hue of the shellac complements the wood and gives it more of an antique look. After applying one coat to the panels, the same surface prep is needed for all of the interior faces of every component. It's going to be much easier to remove mill marks on the inside faces before assembly. Finally, the assembly can begin, and we broke it up into a few stages. First, the doors and cabinet sides were assembled. Then the sawtooth brackets were added to the inside of the side assemblies. While waiting for glue to dry on all of those, we switched to sanding the coves to remain productive, and we finished that day with the final case glue up. The next day, I came back with just a little bit more surface prep on the dartboard side of the cabinets and then glued the connecting rails in place. To make the interior shelves, we used some of the off-cut material from the top and bottom panels. In order to make these sit flush with the shelf supports, but also extend to the walls in either direction, the corners need to be marked and cut out at the bandsaw. It's best to sneak up on the fit in this case. We don't want the shelves to rattle around because we remove too much material, but we want them to be easily adjusted and move freely with no problems when we want them to move. To make the supports, we cut another piece of leftover material to the longest length between the sawtooth brackets, cut a 45-degree bevel on each of the end grain sides, and tested the fit. Once the fit was confirmed, 4 shelf supports can be ripped out of the piece, just like the brackets themselves. And here's how the system should work. Before mounting the doors, we put the top and bottom in place just to get an idea of how the piece was looking. For the doors, we chose to use some soft closing overlay cup hinges. A spacer block is used to elevate the door to the appropriate height, and from there, a center line for each hinge can be drawn on both the door and the inside of the cabinet. These are seriously the easiest hinges I've ever installed. After verifying the drill press placement, all you need to do is drill an appropriate sized hole on the center line that was just marked, screw the hinge to the door, and then attach the hinge to the cabinet with a screw through the center line on the cabinet. It is seriously just that easy. Then you can turn the adjustment screws as needed to align the door. A 3/4 inch plywood back panel was sized to go between the cabinets and in front of the back rails, and we covered that with a thin layer of cork. To give the dartboard more visual interest, we're going to offset it from the cork panel and use these LED lights for a backlight. To eliminate the ugly power cord hanging down from the cabinet, we chose to go with a battery-powered lighting kit. Now the cool thing about this is that it can be run off of either 4 AA batteries or any USB power supply. We had to do a little bit of figuring out, and this is what we came up with. This is just a 4-sided box out of plywood, just glue and brad nails. Just strong enough, and that's all that matters. And it's sized so that it is this plus this will give us the appropriate spacing off of the back panel, which I think this combines to be 6 3/4 of an inch. So what we need to do is first lay out this dead center on this cork piece where it will be visible, where the dartboard will be visible. What I mean by that is this piece of blue tape down here represents the bottom edge of this arch. And we want to center it vertically from the edge of this blue tape to down here, which I've already made my reference notations here that it is 8 inches off the bottom, which puts it perfectly centered. And let's see, 8 inches off the bottom. That means it should be 8 inches on the top side to that blue tape, which it is. And then I have 10 1/4 inch to either side, will be perfectly centered left and right. This is, oh, I was really close. That's 10 3/8, so I'll come back to 10 1/4 and 10 1/4. Just want to verify that that is all the way around. 10 1/4. 10 1/4. All right, so now this is not perfectly centered on this back panel. It's perfectly centered in the visible area due to this arch. So there's a little bit of a difference there. Now what we want to do is trace around it with a sharp knife to remove the cork that we have in the center here. This is the wire that came with the kit, and I've already cut off one end. The reason being is I need to fish this through a hole into this corner post here. And if I have both ends on there, I'm going to have to drill a pretty large diameter hole, much larger than what I want anyway. So I figured out that on this side, this is the side that connects to the lights, it's just a very simple positive and negative soldered connection, so that's going to be very easy to extend. So what I did is I cut it over here, and now I can drill a much smaller diameter hole through this side of the cabinet, and that way I can put the USB side inside the cabinet, fish this wire through that very small hole, and then it'll go into here where it will connect to the lights. Of course, after I reconnect it to this end over here. This is that extension box that we made, and as you can see, we painted it black. I don't know if you can see actually right there, that's a hole we drilled on an angle to fish the wire through for the lights. And the lights will come out here and then wrap all the way around, starting from this side and going in this direction. This side is going to be closest to the dartboard, but this doesn't mount directly to the dartboard. This mounts to another plate that we made, and I've already traced this centered onto this and drilled the appropriate holes on the inside to screw from the bottom side of this plate into this plate. And once that is done, then we can mount the dartboard on the other side of this by drilling right through it into the dartboard. Now that these two pieces are put together, I can put this on the cork side and Sean can secure it from the back side. To make sure the dartboard is attached perfectly center as well as aligned vertically, we used double-sided tape to position it from the outside. Then the platform can be removed and the dartboard can be secured with 4 screws through the mounting plate. After a final disassembly, everything can get any last-minute surface prep and the finish can be applied. We are using the same mix of Garnet Shellac, applying the first coat with a brush, sanding with a 320 grit sanding sponge after the first coat has dried, and then adding a few more coats with a balled up rag. The last thing to do is add the LED lights, install the dartboard for the last time, and secure the top and bottom panels with the tabletop hold-down clips. So as you can see, the dartboard cabinet is done. It turned out quite well, especially considering that this was, I guess you could say, a salvage project. We started with one intention and ended up going a completely different route, and this is the final product. The lighting behind the dartboard turned out quite well. Again, it was a little bit of an experiment. We didn't really know what to expect. I think we hit a good balance between it not being too bright and not being too dark. It's an accent, and that's all we want. We want the rest of the piece to be the showcase and the lighting to be an accent. And because we have the dartboard away from the back wall, it's not in a shadow, so we still have the ambient lighting in the room, whatever room it'll live in, shining on the front of the dartboard.
It's a lot brighter out here too, so it's going to look a little bit more, have that little glow in the back a little bit more than what you're seeing here.
Once we get it out of this shop. So the couple things we have never done before, but we got them done. Woodworking is, there's nothing in woodworking that you can't do. There's always stuff that you just haven't done yet. And there's a few things on here that was the case for us. He's never cut coves on the table saw. How did you like that process?
I think I liked it. It was not as intimidating as I thought it was going to be. It turned out to be a fairly simple, job.
Yeah, once you get it done once, then it's like, oh, well, that's no big deal. Yeah. And then for me, I've never done the sawtooth hangers on the inside of the cabinet. Very simple process, but it's something that it adds a lot of interest to the inside of the cabinet. You could probably get away with a lot less work just using regular shelf pins, but that's interesting.
I think it adds a lot of visual interest. I really, really like that touch.
Yeah. But anyway, if you want plans for this project, the dartboard cabinet, then be sure to check out my website, jayscustomcreations.com. I'll have links to all the important stuff for this project down below. Be sure to check out Sean's website, stoneandsons.net. He's the one who bought all this awesome cherry that we got to work with. By the way, cherry lumber, fantastic if you've never worked with it.
Really nice.
It's one of the best species to actually work with as far as ease of use.
Yep.
But anyway, that's it for this video. You guys take care, and we'll catch you on the next one.
See ya.
See ya.
That's just my sign off.
See ya.